Welcome to this tutorial on NumPy Broadcasting Rules. Broadcasting is a powerful feature that allows you to perform operations on arrays with different shapes without manually reshaping them. Understanding these rules will make your NumPy code more efficient and elegant. Broadcasting is NumPy's mechanism for performing arithmetic operations on arrays with different shapes. Instead of requiring you to manually expand arrays to the same size, NumPy automatically handles this expansion during computation. This means you can add, subtract, multiply, or divide arrays of different dimensions, and NumPy will figure out how to align them properly. Let's start with a simple example. We have an array containing the values 1, 2, 3, and 4. We also have a scalar value of 10. When we add the scalar to the array, NumPy broadcasts the scalar across all elements. The result is 11, 12, 13, and 14. The scalar 10 was effectively added to each element of the array without us having to write a loop. NumPy uses 3 rules to determine whether broadcasting is possible. Rule 1. If arrays have different numbers of dimensions, pad the smaller shape with ones on the left side. Rule 2. Arrays with size 1 along any dimension can stretch to match the other array's size in that dimension. Rule 3. If the sizes don't match in a particular dimension and neither size is 1, broadcasting fails and NumPy raises an error. Let's examine Rule 1 with an example. Array A has shape 3, 4, 5, which means it has 3 dimensions. Array B has shape 4, 5, which means it has only 2 dimensions. To make these compatible, NumPy pads array B's shape on the left with a 1, transforming it to shape 1, 4, 5. Now both arrays have 3 dimensions, and we can apply the remaining rules. Rule 2 allows dimensions of size 1 to stretch. Array A has shape 3, 4, 5. Array B has shape 1, 4, 5. The first dimension of array B is 1, so it can stretch to match array A's first dimension of 3. After stretching, array B effectively becomes shape 3, 4, 5, matching array A perfectly. Broadcasting succeeds and the operation can proceed. Rule 3 handles incompatible shapes. Array A has shape 3, 4, 5. Array B has shape 3, 7, 5. Looking at the second dimension, array A has size 4 while array B has size 7. Neither of these is 1, so neither can stretch to match the other. This violates Rule 3, causing broadcasting to fail. NumPy will raise a value error indicating that the operands could not be broadcast together. Here's a practical example combining everything we've learned. We have a matrix with shape 2, 3 containing 6 elements. We have a row vector with shape 3 containing the values 10, 20, and 30. NumPy pads the row vector's shape to 1, 3, then stretches it to 2, 3 to match the matrix. The result is a 2 by 3 matrix where each row of the original matrix has had the row vector added to it element-wise.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.